Alright, in this section we're going to see now some basic properties for derivatives. Now, when they say the word differentiation, it really means process of finding derivatives. Okay. And the reason it's called differentiation, different, right? It's because it comes from the idea of the formula for slope, right? You have rise over run, and then rise is simply difference of y1 minus y2 divided by x1 minus x2 minus x1. So it comes, the word comes from that. The root of this word comes from that idea. You're taking the difference of the y values, right, the average change, and you're dividing it. But anyway, every time you see the word differentiation means finding derivatives, okay? So it's a basic properties for finding derivatives. So that's what it means. Now, you remember in the previous section that how tedious it is to find the derivative using those four steps in that process. So we have to find rise, then you put f of x plus h, remember that, and then minus f of x, and then divide the whole thing by h, and then you're gonna take that mass and you're gonna simplify it algebraically, and then you make h goes towards 0, and then you get a number or you get a formula, right? Well, fortunately, from now on, from this section on, you don't have to do those four steps, okay? For the previous exercises, I still want you to do it, okay? From exercises from the previous section 10.4, some of the questions ask you to do the four-step process. I really want you to do that. So I want to see you doing that, because and take advantage of that. Do those four-step process in the previous exercises, so you can understand what derivative really means. So that helps you understand. Don't simply do the homework by just following like a recipe, right? A list of instructions. But try to understand what you're doing. Well, from this section 10.5 forward, you don't have to do those four steps, okay? So what we're going to learn in this section is pretty simple. It's simply formulas that you could memorize to get straight to the formula for the derivative, okay? So the very first one, so in this section here, the main idea of this section is avoid the four-step process, right? Because the four-step process is how we find the derivative. But the idea is to avoid the four-step process by memorizing formulas. Okay. So here's the first formula. So we have a function, f of x. It's a function. We'd like to find the derivative. Oh, my handwriting here is horrible. Derivative of f of x. Now they also have different notations for that. Here's the first formula. Okay, if your function, this is on page 527. So formula 1, if your function which is the y, right, the y value. If your function is a constant, this is a constant. guess what happens? If your function is a constant, for example, if your function is f of x equals to, I don't know, 2, right? There's no x in there, just 2. Or, for example, let's say your function is f of x equals to 5. Then the derivative is 0. The slope is 0. Well, you can, that's not hard to understand. If the function is constant, that means if you plot the graph will be simply a straight horizontal line like that. Okay? So what is the slope of a horizontal line? The slope is always 0. Okay? So that means derivative is 0. Okay. So in the book you will see derivative written as f prime of x, right? F apostrophe x. Or you can also say like that. Okay. I mean, you know, f of x is the same as the y value. Okay. So you put the apostrophe on the y. Remember, this is not an exponent. It's just an apostrophe, just a little tick mark there. There is another notation that's it's kind of weird, but it's used a lot. This will be useful later in the semester. Okay, it looks like a fraction. Okay, it's dy dx. It really means that you're doing. This is to remind you that this is rise over run. Okay, the dy represents the change in y, and the dx represents the change in x. They call it infinitesimal change, right? So you divide, the y is changing a little bit, the x is changing a little bit, you're dividing. So this really means derivative. Okay? These are the same thing. Anyway, if the function is constant, then the derivative is 0. That's the first formula. Let's look at the second formula. The second formula is, it's called the power rule. It's on page 528. It simply says that if you have a function that looks like this, we put the y here. Sometimes you'll see y. Sometimes you will see f of x. So both are the same thing. But if you see the formula to be something like this, x to the nth power, that n could be 1, 2, 3, any number, then it turns out that the derivative is n times x raised to n minus 1. Or you can say, same way here, these are the kind of the same thing. Or dy dx. So again, same thing. All right, let me illustrate that with an example, okay? Here it is. Let's say your function is x to the 5th power. So what is the derivative? Well, according to the formula, see, this is it's x raised to n. N in this case, this is your n, it's 5, okay? So this would be, according to the formula, it would be n x and minus 1. Okay, so you put 5, that's what n is, x, and then raised to 5 minus 1, which is 4. Okay, so that's the derivative. So it's very easy. So this is how it helps me memorize the formula. So if you have x raised to a power, bring that power down, okay? So you bring it down, the 5 here, you bring it down, bring it down here, multiplying by x, and then you subtract 1 from that. See, that becomes 5x to the 4th. So it's very easy to memorize. And you can do combinations of the two, and that's what the next formula says, is that formula 3, well, actually formula 3 says that if your function is a constant k, okay, here's another constant, times another function, I call it u. Okay, let me write this down for you. A constant times another function. Then guess what? The derivative is, you repeat the constant, but then you take the derivative of that function there. Okay, maybe you didn't understand any of that. Okay, let me illustrate for you. Here's an example. Let's say I have a function that looks like this. F of x equals to 8x to the 5th. Okay? Okay, in this case, what do? We know how to do the derivative of x to the 5th. The derivative of x to the 5th is 5x to the 4th. But there's this 8 in front of it. Well, you simply repeat the 8. Right? See, that's what it's saying here. So we repeat the constant. And then take the derivative of that function. So here's the derivative of that function is 5x to the 4th, but you multiply, right? Okay, so you repeat the 8, repeat the constant, and then 5x to the 5th, it's 5x to the 4th. Derivative is x. Its derivative is 5x to the 4th. So this becomes 40, right? 8 times 5 is 40 x to the 4th. And then you can do combinations, which is the next formula. You can do combinations of these. So if you have a function that is one function plus or minus another function, then the derivative is simply the sum of the derivatives, the sum or subtraction of the derivatives. So take the derivative of that, and then plus or minus again, and then take the derivative of the second function. Okay, so let's do an example here. Let's say now I have f of x equals to x to the 5th plus x cubed. Well, according to this, see, it doesn't matter if you have a sum or a subtraction. Take the derivative of the first one, take the derivative of the second one, and you add or subtract. So this would be the derivative Okay, this becomes 5x to the fourth, derivative of that. And then for this one, it becomes 3, right? Bring the 3 down, x, and then subtract 1 from 3, 2. So there you go. That's the derivative. Okay, and then you can do, again, combinations of those properties. So here's a final example for you. Let's say I have f of x equals to x cubed minus 15x squared plus 72x. Well, I'd like to see if you can figure this one out. Okay, well, let's see if we can do this. Here is derivative. Alright, derivative of this one is easy. That's 3x squared. Right, to bring the 3 down, subtract 1 from 3, that's 3x squared. And then minus, okay, now what is the derivative of this one here? Well, repeat the 15, right, and then bring the 2 down, subtract 1 from the 2, it becomes 1. So this will be x to the 1. And when the exponent is 1, you don't have to put it there. You know it's 1. Now here is the part, the interesting part. What is the derivative of 72x? Well, we can bring the 72, repeat the 72, and then what is the derivative of x, right? It turns out the derivative of x is 1. Okay. So there are two ways you can see that. One way is to look at x. X is just that straight line again, right? X goes this way. And the slope of x is what? 1. Okay? So the slope of x is simply 1. So this is the derivative of that function is 3x squared minus 30x plus 72.